So for 12A surds, we have these rules that you need to follow. So make sure you write them down in your book. But let's just start applying these rules to simplify these surds. So you got to write them as single surds. So far we have 2 surds getting times together. So what we need to do is just times them together using this third rule over here. As you can see, when they are separated, you can always combine them with a times sign as well. So your answer is going to be square root 2 times 3, which is square root 6. For B, you can combine them using the fourth rule over here. So it'll be 18 divided by 6, which is square root 3. For example 2, what you need to do is write this square root 18 into a form a square root b, where a and b are integers and a is as large as it can be. So what this means is you kind of have to consider the number 18 into its factors. What are its factors? Well, you can do 9 times 2, you can do 1 times 18, you can do 3 times 6. So those are its factors. And what you need to consider is what number is a perfect square number out of those numbers. And hopefully you can see that 9 is the only perfect square number. Well, technically 1 is as well, but that one is a bit useless. So basically what that means is square root 18 can be written as square root 9 times 2. And this means it can be written in this format as well using our rules, which also means that this term over here can be simplified as 3 because square root of 9 is 3, and this becomes your final answer. So where our A is 3 and then our B is 2. So that's what it looks like. Operating with surds, the rules for adding, subtracting, multiplying by surds are pretty similar to the ordinary algebra. So think of it like as a common factor. A like term, I was meant to say. So think of it as 3x plus 5x. Because these two surds are the same, you're able to add them together. So if we do 3x plus 5x, your answer is going to be 8x. So in our case, this is not what we're actually doing. In our case, if we have 3 square root 3 plus 5 square root 3, we're able to add the coefficient parts, kind of this part together, because our surds are the same. So your answer is going to be 8 square root 3. With the second answer, you're going to have the similar thing. As you can see, the surds are the same, so you just take the coefficients. So it's 2 take 5, so it's going to be minus 3 square root 2. Alright, let's simplify this answer. So as you can see, there's a bracket. Just means you have to expand the bracket using expansion rule. So all you have to do is times them together. So 6 square root 5. And then when you times a positive square root 5 and a minus square root 5, first of all, my sign's going to be negative. And then when I times square root 5 and a square root 5, it's just square root 5 squared. I can write it like this, which you hopefully should know. It simplifies down to 5 because those two cancel out. Square root and square gets cancelled out. So this just ends up being your answer. Alright, for B, pretty similar as well. You're expanding again, but you're using kind of the FOIL technique. So what you need to do is start with the first, so that'll be 6. The outer, so that'll be 12 square root 3. You just times numbers together and then leave the square root. And then your inner, square root 3, and then the last, so square root 3 times square root 3 is going to be squared of square root, so that's just going to be 3. So I can simplify this further by going 6 plus 3, which is 9, and then I could collect these two like terms as well. So that's 12 plus 1, so that's 13 lots of square root 3. Alright, example 5, this one is pretty similar as well. You can do FOIL like so. If you already know some patterns from, I think it's called, not difference of two, it was perfect squares expansion. So if you know how to do that, you're more than welcome to do it, but I'm going to show you how to do FOIL as well. So FOIL 25 minus what am I doing? Minus 5 square root 2, and then minus 5 square root 2, and then last, that one's going to be turning into plus 2, so that turns into 27, take 10 square root 2. Now if I use the pattern, if I want to quickly show you, the pattern turns it into a squared take 2ab plus b squared. Now what that means is that a is that first term, so it's 5. B is that second term, so it's just square root 2. So all I have to do is substitute that in. So 5 squared, take 2 times 5 times square root 2 plus square root 2 squared, so that's 2, which turns into 25. Take 10 square root 2 plus 2, which turns into 27. Take 10 square root 2, which you can see that they're the same answer. So if you know how to use this method, you're more than welcome to use that as well. Both should be the same answer. Alright, B quickly. So again, this one's called difference of two factors, I think. Or two, I can't remember what it's called. Difference of two something factors or something like that. I can't exactly remember the name. I'll let you know. But basically, your answer pattern ends up being a squared take b squared. But I'll show you FOIL first. So I'll write it out and show you FOIL first, and then confirm with the pattern. Alrighty, so first, outer, inner, last, so that's -4, and then times 5 because of square root 5 times square root 5 turns into a 5. So that turns into 49 take 20, and then I got 28 square root 5. Oh, actually, one is a positive, so I should make one of them positive. Which one did I get wrong? So first, let me try again. First, outer, so that one was a minus. This one should have been a positive, so let me change that. So these two actually cancel out. That's a bit better. So this one cancels out. So it just ends up being 49 take 20, which is 29. So that's my answer. So if I use this version, my A is that answer, 7. My B is 2 square root 5. So if I just sub that in, it's going to be 7 squared, take 2 square root 5 squared, 2 square root 5 squared, so that's 4 times 5, so that's 49, take 20, which is 29, which is the same answer as you can see. So either one you can use. Alright, let's see if we can do the last one as well. So division by surds. If you have fractions where and the surds are on the denominator, you can remove the denominator, the surd from the denominator by applying by whatever's on the denominator, kind of on the numerator and the denominator. So I'll show you how that works. So if I've got 6 square root 5, if I want to get rid of the square root 5, because we don't like surds on the denominator, all I have to do is times it by square root 5 and divide it by square root 5, and then it'll kind of cancel each other out and get rid of the square root from the bottom. So if I just times these two together, numerators together, it'll be 6 square root 5, and then if I times the denominators together, like these ones, it'll be square root 5 times square root 5, which is 25. So I can leave it like so. B. So again, 35 over square root 7, square root 7 times square root 7. So in order to figure that out, it's just going to be the numerators together. So it's 35 square root 7, and then 7 times, oh, I did this wrong. My bad. So that's a 5. Square root 5 times square root 5 is 5. Square root 7 times square root 7 is 7. So there we go. So this one can be simplified further down because 35 and 5 can be divisible. So it's 5 square root 7. So with this one, similar thing. If you want to, if there's a square root in kind of this format where it's something plus a square root, you can get rid of it by timesing it. Similarly, just changing the plus to a minus. And then if it's a minus over here, changing it to a plus, vice versa. So I'll show you how that works. So these are called radical conjugates, if you want to write that in your notes as well. So for example, this one, if I want to change this into an integer denominator, basically I want to get rid of that surd. I can't, unfortunately, like the example before we have, I would, technically want to times it by square root 2, but unfortunately that doesn't work in this case because it's square root 2 is kind of a part of this 3 take square root 2. So what you need to do, instead of writing square root 2, you've got to write 3 plus square root 2, okay? And then write it on the bottom as well. So it's basically the radical conjugate of 3 minus square root 2, so it's exactly the same, just with a plus instead of a minus. What that helps us with is you times the numerator, so you should be able to write 5 bracket 3 plus square root 2, and you should be able to expand that out. But we'll do that next step. And then for the bottom, it becomes 3 minus square root 2, 3 plus square root 2. Now, if you notice, this is a difference of 2 factors, so it's going to be your a squared take b squared answer, which is going to give you, if I write my a, 3, my b is square root 2, so it's going to be 3 squared take square root 2 squared, which is 2, which is 9 take 2, which is 7. So my denominator actually ends up being 7. I can figure that out myself. And the numerator, I can times expand it out, so 15. And then positive 5 square root 2. So that's my answer. And my denominator is there's no surd anymore, so I'm happy with that. And that's it. You should be able to do more questions.